Assalamu alaikum everyone. You are listening from Nasimujjaman, and today we are going to discuss about the concept map of neural network, and I'm here with Sumaya Afroz and Ahmed Noor Meraj. So let's dig down into it. The fields of deep learning and machine learning in artificial intelligence. With the help of neural networks, computer system can recognize patterns and solve common problems. Neural networks, a subset of machine learning often referred to as artificial neural networks or simulated neural networks, are the foundation of deep learning approaches. By borrowing their name and structure from the human brain, they mimic the way that organic neurons exchange information with one another. Artificial neural networks are composed of node layers containing a node layer, one or more hidden layers, and one output layer. Each artificial neuron or node is connected to other artificial neurons and has a weight and associated threshold. If a node's output exceeds the threshold value specified for that node, it is activated and starts sending data to the following layer of the network. Otherwise, no information is sent to the network next tier. Neural networks need training data to learn and improve their accuracy over time. However, if they are calibrated from precision, these learning algorithms become valuable tools in computer science and artificial intelligence, allowing us to classify and cluster data quickly. Using problem specific rules and conditions, neural networks assist problem solving without requiring substantial programming. Simpler models are employed for many problems with the most complexities and complex mathematical challenges. Once correctly trained, a neural network performs predictions far more quickly than a convolutional program. Character recognition, a growing issue under language processing, is one of the most commonly used fields. Human face recognition, one of the biometric techniques to identify the provided face, is another frequently used field in text and signature verification applications, where the neural network is heavily unlisted. Due to the characterization of the non-face image without dimensions, it is common task. Therefore, via lengthy training, neural networks assist in making complex problems simple. They are frequently employed for object detection, prediction, and categorization. Consequently, layers of neuron make up neural networks. The central processing nodes of the network are these neurons. The output layer forecasts the outcome after the input layer. The one at the bottom has received the input. The majority of the computations needed by our network are carried out by the hidden layers that are present between them. The symbol stands for scalar multiplications. They are responsible for evaluating the significance of each input and the directional transfer function. As opposed to the other components, the transfer function has numerous inputs. The transfer function's task is to combine several inputs into a single input value to use the activation functions. The activation function will then change the result of the transfer function's calculation into a deal that dramatically affect the output. The activation function is frequently nonlinear. Thanks for staying with me. Let's continue with my other group mates.
Assalamu alaikum everyone, my name is Ahmed Noor Meraj and I'm going to talk about regularization in neural networks and backwards propagation. The number of input and outputs units in a neural network is generally determined by the dimensionality of the dataset, whereas the number m of hidden units is a free parameter that can be adjusted to give the best predictive performance. Note that m controls the number of parameters, which contains weights and biases in the network, and so we might expect that in a maximum likelihood setting there will be an optimum value of m that gives the best generalization performance. Corresponding to the optimum balance between underfitting and overfitting, The generalization error, however, is not a simple function of M due to the presence of local minima in the error function. Here, we see the effect of choosing multiple random initializations for the weight vector for a range of values of M. The overall best validation set performance in this case occurred for a particular solution having M equals to 8. In practice, one approach to choosing M is in fact to plot a graph of the kind and then to choose the specific solution having the smallest validation set error. There are, however, other ways to control the complexity of a neural network model in order to avoid overfitting. From what we know of polynomial curve fitting, we see that an alternative approach is to choose a relatively large value for M and then to control complexity by the addition of a regularization term to the error function. The simplest one is the quadratic. Now coming to backwards propagation. How well is your network performing on a certain set, which could be training, testing, or validation? Having a low error is good, while having a higher error is certainly bad. The error is calculated through a loss function of which there are several. One of these, for example, is the mean squared error. It will calculate the distance between the wanted input and the real input and squaring this value. So if your network is outputting, for example, 0.5 but you want it to output 0, then your error will be 0.5 minus 0 whole squared, which is equal to 0.25. But this error is just used to signify how well the network is performing. During backpropagation, the network uses something called error responsibility, through which it calculates how much it should change connection weights and biases. Thank you.
Assalamu alaikum everyone. This is Sumaya Afroz. I'll be talking about decision and training. Let's first talk about decision. Decision are the core of neural networks. It continuously has to decide whether anything is true or false and whether it is a square, circle or triangle. This is the representation of neural network. Here we'll choose three shapes and the neural network will figure out a way to compute and input the likelihood of each from occurring into the final decision layer. Each layer has a computation whether the nodes are given a value. Depending on which node has the highest likelihood or not, the network calculates the probability of each individual answer. The solution is decided upon. Let's assume that if it is a triangle were to form, it would activate, making that particular node's probability the highest. However, depending on which stage of the training the machine is, the final answer could be the either true or it could also be the false. And next part is training. The input that was obtained from the portion which consists of 784 pixels is sent into each first layer neuron as a 3D signal. Each neuron's connection has a weight assigned to it that is sent to the hidden layer for calculation and ongoing adjustment to achieve the best values. The OS update is dependent on the optimizer or algorithm for optimization. The most used optimizer is SGD, which reduces loss or mistake to almost zero. Let's imagine that we want to train our model to tell the difference between cats and dogs. Therefore, we feed our model with data and labels to that data. For instance, if it's a cat, the data also gets the label of cat. For example, if we send an image of a dog through the network, the output will include a probability indicating what the network believes the image to be. Let's assume that the possibility of it being a dog is 0.4%. In this case, the model will most likely be informed that it is a cat because it has a greater probability. However, inaccuracy may also exist here. Predicting something other than what is actually the case, to reduce this, we continuously feed the model the same data, allowing it to begin learning and updating the rates approximately with the aid of backward propagation. Thank you, everyone.